Hi, in this video we're going to be talking about chords and arcs. So starting with a chord is something like this, where we go from one point in the circle to another point in the circle. We just have to have endpoints on the thing. That is different than a radius. A radius only has one point on the circle. It doesn't have two. A diameter is a type of chord because it's got 2 points on that circle. And it also has the special property that it goes through the center. So a radius has just 1 point on the circle, but a chord has two. Um, if we get a central angle, so this is our central angle right here. Central angles go through the center of the circle. They are kind of making a triangle with that chord, but in particular, they make an arc here on the outside. This outside thing is our arc. And then this piece right in the middle there is our chord, where it touches 2 points on the circle, just like this diameter does, but not like the radius, because the radius only touches the circle once. With all of these new terms, we get a nice thing where a bunch of things end up being congruent. So this angle and this angle are both central angles. And if they are congruent, then that means that these two chords out here are also congruent. And if those chords are congruent, then we're also able to say that these arcs out here are also congruent. So we've got congruent arcs. That means we've got congruent chords. That means we've got congruent central angles. All of those things just fit together with each other. So if I look at this example down here, I know that this and this are the same. So if these two central angles are the same, that means that these two chords also have to be the same since they have the same central angle. So then that's a real quick thing that 17 equals x because the chords are congruent if the central angles are congruent. Chords are congruent, central angles are congruent. So if I come over here, I know that these two chords are congruent, so they're both 8. If these are both congruent, then that means that these two angles on the inside have to be congruent. So we get a real quick 96 equals x. Since these are congruent, then those angles have to be congruent by the same logic we had over here. Another theorem we get is if we've got some chords that are the same distance from the center, so this chord and this chord are the same distance from the center, then they have to be congruent. So we're saying that this distance and this distance are the same, then this orange line and that blue line also have to be the same. So if we look at this example down here, I know that this is 73, then this has also got to be 73 because they both have those little double tick mark things. And we know that they are the same distance from the center. So we know 43 equals 43. Since they're the same distance from the center, that means we can say that this line and this line have to be the same. Well, one of them is 73 plus 73, and the other one is just x. Okay, well, just add those together. We get 146 equals x. Done. In this example, we've got that same distance from the center. This x is trying to indicate that half of that chord is x. So then the other side of that chord must also be x. This 7, however, see how it's kind of in the middle? That means that this whole thing is 7. So since these chords are the same distance from the center, we can say 7 equals that x plus x. So this is just going to be a little bit of a solve this time. So 7 equals 2x. And so then we divide both sides by 2. So x has got to be 3.5. Our next theorem or pair of theorems are kind of relating to each other. If we've got this chord that's being cut by our diameter right here, then we end up knowing that these two pieces have to be the same and our arcs have to be the same on either side. Now, this is sort of the reverse idea. If we end up with this like, hey, these two lines are perpendicular and these two pieces are the same, then we end up kind of knowing, hey, that's got to go through the center of our circle. So in this example, I've got my diameter right here, which I'd really actually like to be right here, because then it's going to match the diagram that I've got up top. So what if we draw a new diameter right here that goes through that circle? Well, I know that, hey, these are already perpendicular. And we can say, hey, that 8 is getting cut in half to be two 4s right there. So then we can know that, yeah, for sure, this thing is the diameter of that circle. Then inside of that little triangle here, we're able to get a nice little right triangle that we could apply our Pythagorean theorem to. We could say x squared equals that 4 squared plus 4 squared. So we can figure out what x is. So x squared equals 16 plus 16. So x equals plus or minus the square root of 32, which is really just going to be that positive 32 because we just want that distance, square root of 32. If I found the decimal approximation of that, that's about 5.657 if I just type that into my calculator. In this next example, I've got that line that's kind of our radius, and we could make it a whole diameter, but we could say, hey, that's definitely cutting these two pieces in half, but I want to figure out what this radius part is. So what I'm thinking about is like, hey, I could also draw another radius right there going from the center to the edge of our circle, which again is going to make a nice right triangle that we could solve for. So we could say that x squared equals 8 squared plus 9 squared. So x squared equals, let's see, that's 64 plus 81. So, yep. So x squared equals 145. So x equals plus or minus the square root of 145, which we're really just going to use that positive case of the square root of 145. If we type that into our calculator, we get approximately 12.042 for our answer. In this next example, again, I can see that little right triangle guy happening right there, but that right triangle guy is using just part of this chord right here. So I could say that that chord X is made up of two equal parts, A plus A. If I could figure out what that A is, then that's going to help me figure out what X is. Because since that X is going from the center, I know that these two parts are the same because we've got that little right angle there. So that right triangle is going to require a little bit of solving. So we could say that 8 squared equals 4 squared plus whatever a squared is. So that is 64 equals 16 plus a squared. Minus a 16 from both sides. 48 equals a squared. So a equals plus or minus the square root of 48. Really, we just want that positive case. So that x side that we're actually looking for is going to be the square root of 48 plus the square root of 48. So x is kind of like 2 square roots of 48, but we could type that into our calculator and get a nice approximation, which is 13.856. And there we go. That is it for our video. So just kind of a reminder of all the things that we talked about. If we've got congruent central angles, that means that we've got the same chords, which means we have the same arcs. If we've got chords and they're the same distance from the center, then they are congruent and bisecting each other. And then finally, if we've got a diameter, it's going to cut chords equally in half to make two nice congruent arcs right there. Thanks for watching. Bye bye.